You're welcome to Phenomaths page. In today's lesson, we're going to talk about addition and subtraction of vectors. Let's get it started. That is how we write vectors. That's a vector in the component form. We have other ways of writing vectors. So this time, we're talking about the component form. Maybe along the line, we see the other forms of writing vectors. Okay, so whenever you write a vector like this, the first, you know, variable that you see here, the first component that you see here is called the x component, and the one at the bottom is called the y component. So in all, a and b, they are the components of the vector. You have to know this one because that is the idea that we are going to use to, add or subtract vectors. Now the big question is, how do we add vectors? How do we subtract vectors? In fact, that's the answer to the question. That is here. In addition and subtraction of vectors, we add or subtract corresponding components. Yeah. What do you mean by corresponding components? What are corresponding components? Corresponding means they occupy the same position or place. So let's say something to get a better understanding of it. So let's begin with addition and subtraction. So let's begin with addition. Yeah. So assuming we have this, given A, that's vector A with component x sub 1, y sub 1, and vector B with component x sub 2, y sub 2. How do we add? So that's going to be the vector A plus the vector B. What are we going to get here? We just have to do substitutions. The vector A is this one, or it has this component. So I just have to do substitutions here. So that's going to be, x sub 1, y sub 1. The operation is plus, that is addition. So plus the vector B, that is this one. So that's going to be x sub 2, y sub 2. So what do we do? The condition is saying that we should be, to be able to add vectors, we have to add corresponding components. Corresponding, that means they have the same position. So x sub 1 and x sub 2, they are occupying the same position. In fact, they are all on top. So we can add the two of them. So that's going to be, x sub 1 plus x sub 2. We come to the ones at the bottom. So that's going to be y sub 1 plus y sub 2. So that is how we can add the vectors. Let's come to, you know, subtraction of vectors. So this time we are going to subtract. So we have the vector A minus the vector B. Let's do substitution like we did in the first one. So vector A has component x sub 1, y sub 1. This time the operation is minus. The vector B has component x sub 2, y sub 2. So let's begin with our first question. Given the vector P with component 3 and 2, and vector Q with component 2, negative 5, we have to find I, P plus Q, and I, P minus Q. Let's begin. So let me work the I here. So the vector P has been given as 3, 2, and the vector Q has also been given us 2, negative 5. And we have to find the vector P plus Q. So we can do substitution straightforward, right? So that's going to give me, the vector P is equal to 3, 2. The operation is addition. And the vector Q is 2, negative 5. So what do we do next? Remember the condition that we are going to use. We add or subtract corresponding components. So that is what we are going to do. We are going to add or subtract corresponding components. And what are the corresponding components in this case? 3 and 2, they are corresponding. They occupy the same position. So that's going to be 3 plus 2. We come to the other ones, that's going to be 2 plus negative 5. I've kept in bracket because of the negative sign. So let's see what you're going to get here. 3 plus 2 will give me 5, straightforward. And 2 plus negative 5 is the same as 2 minus 5. So that's going to be negative 3. So that is how we can, find the vector p plus scale. Let's come to the vector p minus scale. So we can work the second one here, that is p minus scale. So we have p minus scale, the vector p minus scale. Let's do substitutions like we did in the first one. So the vector p has components, 3, 2, minus the vector scale. It has component 2, negative 5. So we have to use the idea, subtracting corresponding component. So we have 3 minus 2. And we come to the y component. That is going to be 2 minus negative 5. I hope you have seen that. You have to take note of that when the signs are the same. So you're going to get something like this. We can simplify this basic arithmetic. 3 minus 2 is going to give us 1. And 2 minus negative 5 means 2 plus 5. I mean, the negative minus, or the minus negative is going to be plus. So we have 7. So that is how we can get, the next one too, that is p minus scale. Given our second question, the vector A has component 2, 7, and the vector B has component 1, negative 2. Vector C has components negative 3, negative 5. And we have to find the vector A plus B minus C, and the I is there. Let's begin with the first one. That is I. But to find the vector A plus B minus C, with information given already, we just have to do substitution. So the vector A has component 2, 7. So you just have to write 2, 7. We are doing substitution direct. Plus the vector B has components, that is this vector. It has component 1, negative 2. The next one is minus vector C, that is negative 3, negative 5. So that is the correct substitution for you. We just have to add and also subtract corresponding components. So in this case, we have 3 vectors, and 2, 1, and negative 3, they occupy the same position. So that means they are corresponding. So you're going to get 2 plus 1, minus negative 3. You have to be careful when the signs are repeating themselves. So you're going to get negative, 3 here. The y component, we have 7 plus negative 2 minus negative 5. You have to check the signs. They are very, very important. So how do we, simplify this one? This is basic arithmetics. So we are going to get 2 plus 1 is 3, minus negative 3 means plus 3. We come to the y component, and we have 7 plus negative 2. That's the same as 7 minus 2. That will give me 5. Minus negative 5 is going to be plus 5. So this is what I'll be getting at the end. 3 plus 3 will give me 6. And 5 plus 5 is going to be 10. So that is how we can find the first one. Let's get the second one here. Okay, so let's work the second one here. That's going to be I. And I is B, the vector B minus the vector C plus the vector A. So this time, the letters have been mixed, so you have to be careful. So let's do the substitution right here. The vector B has components of this one. That is this vector. So we have 1, negative 2, minus the vector C. Let me shift it to this side. So the vector C has components negative 3, negative 5. So plus the last one. That's going to be the vector A, which has component 2, 7. So we can, add corresponding components. we are going to get 1 minus negative 3 plus 2. That will be the x component. So we have 1 minus negative 3 plus 2. For the x component, we come to the y component. So that one is going to be negative 2, this one, minus negative 5 plus 7. So you're going to get negative 2 minus negative 5 plus 7. So let's compute this, arithmetic. So 1 minus negative 3 is going to be 1 plus 3. So let me just simplify it here. 1 plus 3 plus 2. Let's come to the, y component. So that's going to be negative 2 minus negative 5. That's going to be negative 2 plus 5 plus 7. So let's get our final answer. 1 plus 3 is 4, plus 2 is going to be 6. Negative 2 plus 5 is going to be 3, plus 7 is going to be 10. Wow. So coincidentally, we are getting the same answers. 6, 10, 16. So let's get our next question here. If the vector m has component half 3 on 2 and the vector n has component 5 on 2, 3 on 2, we have to find the vector m plus n. An interesting vector or vectors, very long. The components are fractions, We're going to use the same idea. So let's get it started. We have m plus n, and we have to do substitutions. The vector m has component 1 on 2, 3 on 2. We come to the vector n, very long one. So we have 5 on 2, and that of, 3 on 2. So these are the vectors. How do we add them? Because this time we have, fractions. The idea is going to be the same. And what's the idea? We are going to, add or subtract corresponding components. That is what you have to know. Okay, so we have to add 1 on 2 plus 5 on 2. That will be for the x component. Let's come to the y component. 3 on 2 plus 3 on 2. So regardless of the components of the vector, when it comes to addition and subtraction, we just add or subtract corresponding components. So let's continue. We have to simplify or solve these, arithmetic here. They are common fractions with, the same denominator. That means they are like fractions. We just have to add the numerators. We take one of the denominators. This is common, to you. So we're going to get 6 on 2. The y component, we are going to get 3 plus 3. That's going to give us 6 on 2. The same thing. So 2 goes into 6. We can simplify. Yeah. So 2 goes into 6 3 times. So we have 3 times here. And 2 goes into 6. It's going to be the same thing. So that is what we have. So the answer is 3. 3. That's the vector. That's the answer. Let's take our last question. So let's take our last example. And this is what we have. We have the vector AB with component -2, -4, and vector BC with component 3, 2. We have to find the vector AB plus the vector BC and the vector BC minus the vector AB. So that is another way of writing vectors. It's not always going to be the small letters or the position vectors. It can be something like this. You can use the block letters to, write vectors. Take note of that. So let's start with the first one. That is I. We have to find the vector AB plus the vector BC. So let's get our substitution done here. The vector AB has component -2, -4, plus the vector BC also has component 3, 2. So that's just simple. We have to add and also subtract corresponding components. So you're going to get -2 plus 3. We come to the white component. We have -4 plus 2. So that's going to give me Negative 3 plus 2, negative 2 plus 3 is going to give me 1. And then negative 4 plus 2 will give me negative 2. So these are basic arithmetic that you have to know. Let's come to the next one. Okay, so let's get the last one here. That is I. Let's get it here. We have to find a vector BC minus the vector AB. So let's do our substitution straightforward and see how we can tackle it. So the vector BC is this vector, so which has component 3, 2, minus the vector AB, which also has components negative 2, negative 4. So let's do our simplification. So we're going to get 3 minus negative 2 and that of 2 minus negative 4. I hope you're not confused. We're just subtracting corresponding components. So 3 minus negative 2 is the same as 3 plus 2. And 2 minus negative 4 is the same as 2 plus 4. So our answer is going to be, 3 plus 2 is 5 and 2 plus 4 is 6. So that is our answer.